What is the universe? The universe is defined as all space and time and its contents. The universe may refer to concepts such as the world and nature. The universe is often defined as the totality of existence, or everything that exists, everything that has existed, and everything that will exist. There are physical laws that influence energy and matter, such as conservation laws and classical mechanics and relativity. How old is the universe? The universe is thought to be about 13 billion years old. By measuring the ages of the oldest stars and the rate at which the universe expands, scientists arrived at that number. They also measured the expansion by observing the Doppler shift in light from almost all the galaxies which travel away from us and from each other. Galaxies travel faster the further they go. A galaxy will be so far away in the distant future that its light will not be visible to Earth. The matter, energy, and everything in the universe was more compact last weekend than they are today. The same can be said about any time last year, a million years ago, or a billion years ago. The universe is not just one point. The universe expanded over time as space did. The universe didn't exist at all. That the universe was not a dark, empty space from which all matter sprang forth. How has our view of the universe changed over time? We humans have had little or no means of understanding the universe for countless lifetimes. Our ancestors instead rely on myth to explain the origins of everything they know. We have repeatedly leaped forward in our knowledge of the universe since then. Approximately 100 years ago, astronomers first observed a group of galaxies beyond our own, and only a half-century has passed since humans have sent spacecraft to other worlds. When people began to investigate the nature of things a few hundred years ago, they were called natural philosophers instead of scientists. With ever-increasing technology and knowledge, and with no shortage of imagination, humans continue to lay the ground for the mysteries of the cosmos. But we have yet to send a space probe to even the closest of the billions of other star systems in the galaxy. No one has explored all the planets in our solar system. The universe is 11.4 billion years old. Our solar system is 4.5 billion years old, and humans have been around for a few thousand years. This means the universe has existed 56,000 times longer than our species has. Humans have been living on Earth for about 56,000 years. Almost everything that has ever happened to humans has happened before. Support of life. According to the fine-tuned universe hypothesis, the existence of observable life in the universe can only occur when certain universal fundamental physical constants lie within a very narrow range of values. If any of the fundamental constants were not slightly different, the universe would not have been able to support the establishment and development of matter, astrophysics, and life. Spacetime. In general relativity, the gravitational force is reimagined as the curvature of space-time. It is not the result of a force deflecting a body from an ideal straight line, but rather the body's attempt to fall freely through a background that is curved by the presence of other masses. The Newtonian gravity theory is a good approximation of the predictions of general relativity when gravitational effects are weak and objects move slowly compared to the speed of light. It is empirically true in most of the universe with high accuracy. Average space is observed very nearly flat with a curvature close to zero. Spatial time also appears to have a simply connected topology, in analogy to a sphere, at least on the length scale of the observable universe. A cylindrical or toroidal topology may also exist as seen in two-dimensional space. The universe could also have a multi-dimensional global topology, such as that of a sphere or a two-dimensional space. There is a multiplicity of dimensions in the universe as shown by string theory. It may also have multiple dimensional topologies, such as toroidal or cylindrical topologies of two-dimensional space. Dark energy. Why the universe is expanding remains elusive. Two proposed forms of dark energy are the cosmological constant, a continuous energy density filling space homogeneously, and scalar fields, such as quantum entanglement or dynamic quantities, whose energy density can vary. The cosmological concept can be formulated as equal to vacuum energy. Scalar fields with only a small amount of spatial inhomogeneity would be difficult to distinguish from a cosmological criterion. Thank you for watching. Do subscribe, like, and share.